Good afternoon. Today we're discussing 2.2 Analyzing Linear Function. Our goals for today are I can complete tables, draw graphs, and write equations to model linear situations, and I can determine the solutions using tables, graphs, and functions. All right, so here's the first scenario. I have $2,000 in my health savings account, and each month there is an automatic withdrawal of $50 for a hospital bill. So the first thing we need to do is identify the independent dependent quantities and their unit of measure. So to do that, just like we did in chapter 1 and section 2.1, we decide what two things are changing. And my balance is changing, and it's changing over time. All right, so, and my balance depends on how many months have gone by. So my independent quantity is time and months, and my dependent quantity is my balance, and we measure that in dollars. So now that we have identified the independent and dependent quantity, let's complete a table. All right, so the first thing is the independent quantity. All right, so the independent quantity was time, and our unit was months. And our dependent quantity was my balance, and it was measured in dollars. And you can either write the word dollars or you can use the dollar symbol. Either one's fine. All right, so the next thing is figure out how much money we had. Well, in our previous examples in section 2.1, it always started out at 0. However, in this particular scenario, it says I have $2,000. So I started out with $2,000. All right, so if I started out with $2,000 at 0 months, I would have 2,000. Right? Then we would need to figure out after 2 months. Well, if they're withdrawing $50 each month, after 2 months, 50 times 2 is 100. So they would have taken out $100. And 2,000 minus 100 is 1,900. So after 2 months, I would have $1,900. All right, then 4 months. 50 times 4 is 200. So they would have withdrawn $200. And 2,000 minus 200 is 1,800, or $1,800. So after 4 months, my balance in my ASA would be 1,800. Okay. Well, this situation is different because instead of them telling me how many months, they give me my balance. So I need to figure out how many months it has been for my balance to be $1,000. Well, if my balance is 1,000, that means they have withdrawn $1,000 total. And to figure out how many months that has been, and since they withdraw 50 each month, we divide 1,000 by 50. And what do you get when you do 1,000 divided by 50? Hopefully you got the answer 20. So it will take 20 months for my balance to reach $1,000. Right? And then my next balance is $500. So we take 2,000 and subtract 500. And that leaves me with 1,500. So they have withdrawn $1,500 total. So to figure out the number of months, we divide that by 50. So you take 1,500 and divide it by 50. And that gives you 30 months. So it would take 30 months for my balance to reach $500. Okay. Now we need to come up with the expression. Well, previously in section 2.1, it was always the rate of change times the independent quantity. Well, that's the same thing you do here. You take the rate of change and multiply it by the independent quantity, because each month they're taking away $50, so that would be 50t. But since they're taking away 50, we put negative 50t because they are withdrawing $50 each month. It's decreasing. My balance is decreasing, so we do negative 50t. And the other difference in this scenario is that previously we always started at 0. And in this situation, we do not start at 2,000. So I need to put plus 2,000. And there you go. There is your expression. Negative 50t plus 2,000. Okay. The next says, write a function h of t to represent this situation. Well, you already have your expression, so you just need to write h of t equals negative 50t plus 2,000. So that is our function. Right. The next thing you need to do is get out your book, and you need to turn to page 88, and we will read the scenario and we will complete the table on number 2. So you can pause the video so that way you can get out your book and follow along and complete the problem in your book. All right, on page 88, problem 1. It says, at 36,000 feet, the crew aboard the 747 airplane began making preparations to land. The plane descends at a rate of 1,500 feet per minute until it lands. Number 2 says, complete the table to represent this problem situation. So the first thing we need to identify is the independent-dependent quantities. Well, we're talking about the height of the plane, and it says it descends at a rate of 1,500 feet per minute. So my independent quantity would be time, and my dependent quantity would be height or altitude. Right? The time is measured in minutes, and the height would be feet. Okay. At 0 minutes, it says the plane is at 36,000 feet. So at 0 minutes, the plane's at 36,000 feet. Okay. Now we need to figure out 2 minutes. Well, it says it's descending at a rate of 1,500 feet per minute. So we do 1,500 times 2. And that equals 3,000. And 36,000 minus 3,000 is 33,000. Right. Now it wants 4 minutes. 1,500 times 4 is 6,000. And 36,000 minus 6,000 is 30,000. So after 4 minutes, it would be at 30,000 feet. Okay. The next one's 6 minutes. 1,500 times 6 equals 9,000. And 36,000 minus 9,000 is 27,000.